Alright, this flying theory, I'd like to look at the altimeter in the aircraft. Now let's put the aircraft on the ground at the runway and we'll sit it on the tarmac. What I want to do is watch the altimeter, because the altimeter can change as the aircraft is sitting on the ground. It changes as the pressure of the environment changes. So we're going to have to go over a long period of time. And somewhere there's mean sea level, and let's put this altitude of the airport at 2,000 feet. That's the altitude of the runway that we're dealing with. It is 2,000 feet above mean sea level. That's not going to change because that's geography. However, the air pressure around the environment can change. Now, let's put on the dial in the altimeter. Let's put on the dial 1013. And let's just say, for argument's sake, this reading gives us 2,000 feet. So it says that this aircraft has a pressure height of 2,000. Well, it's just convenient that the pressure height is the same as the altitude of the airport. However, it's 2,000 feet above the pressure line of 1013. Now, of course, as you go higher and higher, the air pressure gets less and less. Now, as you fly higher and higher, every time you fly, as you increase your altitude by 30 feet, each time you go up by 30 feet, the air pressure reduces by 1 hectopascal. The air pressure reduces by 1 hectopascal. There's less air particles. So the more air particles, the more air pressure. The less air particles in a given area, a given space volume, the less air pressure. So this altimeter says it's 2,000 feet above the 1013 pressure level. And let's say that it just so happens to be 1013 hectopascals at mean sea level. That's the ISA model. So what we're saying is we are 2,000 feet above mean sea level. We are also 2,000 feet above the 1013 hectopascal pressure line. Okay, now the aircraft is sitting on the runway, but if that runway wasn't there and it was flying in the air, it would be flying at 2,000 feet at the moment, because it's 2,000 feet above mean sea level, although it's on the ground, so it's not, there's no height, no above ground level height values. What I want to do is adjust the air pressure here at the airport. So what happens if the air pressure reduces at the airport, and all of a sudden there's not as many air particles in the area at the airport. So I'm just going to, I don't want to take out the world, I want to leave the earth there. I'm just trying to take out some air particles. So let's say that the pressure at mean sea level is dropping. Let's say it drops by 3 hectopascals. Now the pressure at mean sea level has dropped down to 1,010. Well, what's going to happen on this altimeter in the aircraft? So it hasn't moved. We can walk out from our little club, and we can walk over to the plane, have a look in the cockpit and have a look at the altimeter, and you will notice that if the air pressure is reducing, the plane thinks it's going up into the air. So what's going to happen here is we're going to increase 3 hectopascals less. So for every hectopascal reduced, it's going to increase by 30 feet. So it's going to increase by 90 feet. So it's going to move to 2,000, almost 2,100. Alright, so it's almost gone up to 2,100. It is now going to be at 2,090 feet. Well, the aircraft thinks it's going up in the air because the hectopascal has reduced. And that's exactly what happens if you're flying. Notice the whole time we stayed at 2000. If you're flying along at 2000 and the air pressure suddenly drops by 3 hectopascals, then the altimeter is going to increase by 90 feet, and it's going to make you think that you're actually getting higher and higher altitude when you're not. You're flying into a high pressure zone. You're still only 2,000 feet above the ground. This is pressure height. The pressure height is being adjusted on the altimeter. So the pressure height is now 2,090 feet, because by rights we're actually 2,090 feet above the 1,013 hectopascal line, which has dropped below the 1,010. So it's now below mean sea level. Okay, let's talk about another scenario. Let's say from 1,010, okay, it suddenly goes up to 1,015. Now the hectopascal has increased from 1,010 by 5 hectopascals. That means the aircraft will think that it's going into a high pressure zone. It thinks it's coming down by 150 feet. It will drop by 150. So this needle will then go back 150, almost drops 200 feet, and it'll go down to, wait, don't want to rub out the circle. It will drop by 150 feet, and that's down 60 below 2,000. That will be 1,940 feet. It thinks it's at 1,940 feet, not 2,000. And that is simply the aircraft still sitting on the ground. It's still at 2,000. The whole time it was at 2,000. So when the air pressure reduced to 1,010, the altimeter went up 90 feet. When the air pressure then increased from 1,010 up to 1,015, then the needle dropped down to 1,940 feet, because the plane thinks it's actually going down into a higher pressure zone. And that's exactly what happens if you're flying at 2,000 and you fly into a high pressure area. The needle will drop. Now you're still at 2,000. The scary part is if you're flying into a low pressure area and it looks like you're going higher, well, and you're actually only at 2,000, be careful, because if there's mountains at 2,000 feet and you think you're flying at 2,090, you can still fly into mountain, because reality, the needle is wrong. The altimeter is deceived. It's being deceived by the air pressure. So you have to know what the air pressure is wherever you are. So especially when you're low to the ground, this air pressure down here, 1,015, this air pressure 1,010 at mean sea level, we call that QNH. And the name I'll just put here, QNH. The QNH is the pressure at mean sea level. So if the QNH changes, well then so will the altimeter reading, and so you've got to adjust, you've got to keep in mind that as the pressure changes, so will the measurement on the altimeter. And just to revise, if you go up one hectopascal, if the pressure increases, that means you drop by 30 feet on the altimeter. We'll think you come down 30 feet. If you reduce your pressure by 1 hectopascal, the plane will think it's gone up by 30 feet, and you will get an increase of 30 feet on your altimeter, even if the plane's sitting on the ground going nowhere. But that also happens while you're flying straight and level. So as you change pressure areas, be careful, because this needle can be adjusting and you could be maintaining the same height. So be aware of how QNH affects the actual altitude of your aircraft. It makes you think you're at a different height when in fact you are at only 2000 the whole time, even though it looks like it's at 2090, even though it looks like it's at 1940. So I hope that this has given you a little bit more understanding about QNH and altimeter readings. Until I talk to you again, stay happy.